Hi, everybody. Thanks for being here. So my name is Alex, and like probably all of you, I'm a GIS practitioner, but I work mostly on drought in West Africa, and specifically how that drought impacts livestock movements. And today I'm going to be talking about a program called GARBAL, which is a call center that serves Earth observation data to farmers and herders in West Africa. So let's talk about our area of interest and our users first. Now, the users of this program are pastoralists, which is a term some of you might know, but when we talk about pastoralists, we're referring to people who herd livestock for a living. It's the dominant livelihood mode in the Sahel, which is this zone that you see in the box there from Senegal in the west to Chad in the east. It's a semi-arid zone. It's where the Sahara meets the savanna. And pastoralism is the dominant livelihood mode. So dozens of millions of people practice this livelihood. And it involves moving your animals in accordance with the season to find pasture and water. Now, the Sahel basically has, it's big, hot, and dry. But as you can see from the bottom right, that has become more and more volatile, the climate. There's been increasing climate change, which has rendered the seasons more and more volatile. So this chart here that I'd like to point your attention to is the precipitation anomaly every year. So the millimeters deviating from the norm, from the 50s to about the present day. And what we can see is, rather than a necessarily linear trend towards more or less rainfall, we're seeing a more volatile situation. You can have a drought year that's immediately preceded or followed by a flood. For people who depend on naturally occurring biomass and water for their livelihoods, this puts them in a precarious situation. The changing of the seasons is particularly important for pastoralists who need to move their animals in accordance with the season. Now, on the right here, you can see a calendar that shows the seasons and when the animals move. So you have July to October, which is the rainy season, and then you have what's called the transhumance, which is when pastoralists will move their animals, sometimes hundreds, sometimes even thousands of kilometers over the course of an entire year in search of pasture and water. Now, in order to affect these movements, they need data. That data is, will it rain? If I intend on selling my animals, what's the price of animals and cereals? Is there pasture? Or importantly, is there pasture left? Has there been a wildfire? Is there infrastructure? Are there veterinarians in this area? All of these are important questions that govern the decision whether or not they will move and where. And there are systems that gather this data. They're excellent systems, but the systems are costly and oftentimes require sending family members ahead of time, sometimes on a motorcycle to scout an area, or calling contacts or family members in neighboring areas. So there are systems to measure this, but they are very costly and time-consuming. Now, to give you an illustration of what seasonal change looks like, these are two images taken 6 months apart from each other in the same spot. On the left, this is the wet season. So this is September. This is a place in Mopti in central Mali. You can see it's lush, it's green, there's a visible lake. Here, this is June. That's the same tree. This is not a drought year. This is not a particularly anomalous year. This is just a regular year. So you can understand that if you're moving your animals, understanding where there's still going to be pasture, where there's still going to be water, it is a very delicate decision-making process, which is where the GARBAL system comes into play. So in 2015, this system was launched. It's a call center that operates in Mali, Niger, and Burkina Faso. And it provides answers to a lot of the questions that pastoralists need to ask. Is it going to rain? Has it rained? Is there pasture? Using Earth observation data and field data. In Burkina Faso in 2022, the center had about 1 million calls. So it's had a pretty good uptake over the past few years. It's governed by a consortium that includes telecom operators. In Burkina Faso and Mali, it's run by Orange. The telecom provider in Niger, it's Airtel. The sort of lead of the consortium is SNV, a Dutch NGO. We, as the technical partners, are Hofslot Spatial Solutions, which is a Dutch geospatial company that provides some of the more technical GIS work. And then the ministries of livestock and producer cooperatives are also heavily involved in the process. So some of the use cases. The main one that we talk about is herders. Right, like this is the most, this is the case that where it was really started on was how to get pastoralists and herders better information about pasture and water in a timely fashion. But we also have sedentary farmers, people who don't move with the seasons, calling in pretty often, sometimes just wanting a simple weather forecast, trying to figure out the best times for planting, people who want to know information about market prices, and we also get casual callers who just want to know if it's going to rain or not. So how does it work? What's the information chain? Essentially on our end, we collect Earth observation data on NDVI, biomass, surface water data sets, weather forecasts, a lot of data that you all are very familiar with, and we package it into a dashboard. That dashboard is accessed by call center agents who read out the information in local language when the end user, or in this case the farmer or the herder, calls in. So what we really like about this system is the end user does not need internet access, does not need access to GIS data, doesn't even need necessarily a smartphone. Just a regular phone call is what they need to get the data. So here's a better illustration of this. Right, so we've got our pastoralist, our herder. He is calling the call center. He wants to know how's the pasture in Tessit. That's a village in northern Mali. The call center agent pulls up data on vegetation, NDVI, small water bodies data. They have access to field data. What they really want is this map, right? So this is a biomass anomaly map. Basically, all you need to know is green good, red bad, okay? So looks at Tessit, this area in the black rectangle, and this is a big red spot. So decides, you know what? Pasture in Tessit, not so good right now. This is a screenshot of one of the interfaces, the one we use for Burkina Faso. And since I think we're okay on time, I'd actually like to just do a quick demo. So basically the way it works is this is what the call center agent sees. By the way, all of the interfaces are public. I'm going to be sharing the URL at the end so you all can access or play with the data. And in most cases, the call center agent, for instance, they have the map already, which shows the latest NDVI data. It's a bit hard to see, but there's weather for all the major cities. But in this case, call center agent gets a call for Bulsa. Let's just give an example. That's a village in Burkina Faso. Pulls it up on the search. Bulsa brings up the point here. And we immediately have the raster data, which is rendered into a textual analysis on the left. So what's great is when you're getting a call, as a call center agent, you want to be able to provide quick responses. Analyzing a map, it can take some time. So we have sort of the highlights here. We have where's the nearest water point? How many hectares of water have been detected last? When was the last image taken? So this was a Sentinel-2 image taken 9 days ago. Then we have infrastructure data. Right? Where is the nearest borehole? 12 kilometers. How much did it rain? There was a light rain in the past 10 days. And then what we get the most often is weather forecast information. What's the weather forecast looking like over the next 7 days? And then what's the seasonal forecast? When, if you're a farmer, when should you start planting? We also have, it's also possible to change views. You can add your layers, you know, as it's a web GIS, so you can look at all sorts of different data. But really, this is where the decisions are made in this dialog box on the left-hand side. Oh, how do I get to the view? I am not good at computer. Ah. So, how does it work? Probably the part that is more interesting technically is the actual infrastructure, right? What's the architecture of the system? So we have automatic downloads of Copernicus data, and then an access to the Open Weather Map API, and then field data, which all gets housed on our local server. And we have a scripting client, which then turns it into location-based data and text. This is all served onto map server, which is then, we have worked with open layers to build the interface that you saw, which is then given out to the call center agents. So really, again, where the bulk of the work happens is it's in here, in the dialog box, where we can provide the textual readouts. That has been the most important part, because that has required more than just giving numerical values. We've had to translate a lot of the data into terms that make sense. You know, for instance, simply providing NDVI readouts in raw numbers doesn't really give a lot of actionable information. So we have to say, for instance, the pasture conditions are good, fair. Rainfall data, has it been strong? Has it been moderate? Has it been weak? So I'd like to focus a little bit on some of the lessons that we've learned throughout this process, because this has been a very, it's been a non-traditional project with a non-traditional user base. There we go. All right, thank you. So the first point that I kind of want to bring up that I think is a lesson that others who are working on these sorts of projects could take into account is the idea of inclusive design. I know this is a buzzword that gets bandied around a lot, but it actually is meaningful if you don't tokenize it. I've seen a lot of projects that involve participatory design where end users are consulted in a tokenized manner, right? Which is you present them the product and you say, hey, do you like this? Check yes. But we decided to instead involve farmers and herders in the design process from the beginning. Now, this is a group with low internet access, many times low literacy, a non-traditional GIS user base. So we can't exactly invite them to contribute to a GitHub repository. Surveys are oftentimes difficult to enact, so how do you do it? You have to build new tools. And in our case, we did a lot of participatory mapping, where we basically printed out these large posters in A0, and we had pastoralists map out where are their routes, where are the important zones for pasture, how have these changed over time, which gave us an idea of where the important areas to focus on, and you know, what does a lot of this Earth observation data mean for the people who we are actually trying to help with who are actually trying to provide this data to? What does it mean? Another important point is on UX. There have been some really great presentations here on UX that I've seen over the past couple of days. And one thing that I'm kind of happy to see is, even though many in our sector kind of overlook cartography or overlook design, I think as a community, we're starting to come to understand that our experience as GIS people is not necessarily the same as other users of our map. So let me give you an illustration of this. On the left, this was our original design. It's a little hard to see with the resolution, but it was designed by GIS nerds, kind of for GIS nerds. We had maps that were monochrome green, which allowed you to see gradients of biomass changes. So, you know, someone looking could say, oh, this was, you know, 8,000 instead of 9,000 kilograms of biomass per hectare. We had we had possibilities to switch between layers. We had granularity and detail. And we focused on the map. The map was really the centerpiece of the interface. This was not what the call center agents wanted. And we had not really built the most user-friendly interface. So we, again, as a bunch of GIS nerds, really had a hard time being able to branch out. So we got what's called map therapy, where we hired an external expert who specializes in getting your maps to tell a story to different types of audiences. So it's a specialized type of UX work that really focuses on maps and storytelling. Yeah, so I would definitely consider looking at mapboss.com. Amber Boss did a great work with us. And we changed the design. So instead of having a map-focused interface, we have a text-focused interface, because that was where the decisions were being made. On the map, instead of having granularity and detail, we focused on quick readability with high contrast, being able to quickly identify things. So those big orange boxes that show the weather readouts. The weather was the most frequently requested data point that we had. So we made it the most visible, the thing that is immediately drawn to the eye. And then for the base map, we focused on lighter colors. And we really only focused on showing large changes in NDVI with high contrast, light over dark. And the final points that I want to sort of share is that we found that it's important to balance spatial and temporal resolution. So higher resolution is not always better, right? We have this trend among the community to go towards, bigger, larger processing. Bigger, larger data sets that, have heavier processing time. Is it always worth it? Is it always worth the noise? Not really. Well, sometimes. I mean, is faster data better? Yes. If you're looking at weather forecasts, absolutely. You want up to the minute. But if you're measuring pasture growth, that's not really something that changes minute by minute. And the second point is about meeting your users where they are. So again, this idea of inclusive design, one of the things we noticed was we were relying on cardinal directions. So in the interface, it would say, your nearest water point is 27 kilometers to the northwest. Wasn't really a great indicator. So we started using landmarks instead. So we did a lookup, pulled a bunch of OpenStreetMap villages, found a threshold for which villages we could identify as known landmarks, and then said, okay, it's 27 directions in the village, in the direction of this village. It came a lot better. The same thing with weather data. It wasn't enough to say we are expecting 12 millimeters tomorrow. We had to be able to translate that into something that made sense for people. So one of the things that we did was we asked a lot of farmers and herders, okay, what does a heavy rain mean for you? Oh, well, a heavy rain for me is when, this creek rises to this level. And so we looked at that and said, okay, that's interesting. Then we talked to meteorologists. What is the rainfall that makes this happen? And we realized, okay, these are actually the numerical thresholds that go from light to medium to heavy. So we asked questions, and we did our best to listen, and we translated that into textual readouts that made sense for that context. And the last is don't underestimate the power of simple solutions. Again, I'm so sorry, I know this sounds like a buzzword, but it was something that we took a little while to realize, actually. We spent a lot of time making these really complicated products. We got this land use product, we had these specialized NDVI anomalies, and the most used product we have is the weather forecast. That's what the vast majority of people want, is they call and they want to know, hey, is it going to rain? Is it not? And so I would encourage all of you to, if you are interested in this, to have a look at the interface. I think what I really like about this project is, I think that we've seen this revolution in the past 20 years towards open data and open Earth observation, right? For us, it's a lot easier to know more about the planet than we ever have before. But the thing that I find troubling is for the vast majority of people who are the most vulnerable to climate change, a lot of this information doesn't really reach them in channels, and it could. So I would encourage you to have a look at the interface, check out the data. You can get in touch with me. We are happy to talk, hear your comments, your concerns, your questions. And yeah, thank you for your time.